Hello student, good morning to all of you. How are you? I hope you all are happy, healthy and very fine at home. What did we discuss yesterday? Yesterday we discussed about the transfer of chirality with the help of one example, I think 2PGF2 alpha, that is one of the target molecule we have considered, and with the help of that example we have seen how the transfer of chirality can be achieved or can be done with that example we have seen. So right now today we are going to discuss about the scaffold process, that is a scheme number 9, and from scheme number 9, from that we can understood what does the scaffold process and what is that. Let us see the explanation about that one. A unique form of manipulating the carbohydrate structure is based on constructing a segment of the target around or on top a rigid entity, such a ring. Then once the derived level of functionality and the chirality is reached, the original carbohydrate position of the molecule is unfolded to unveil the target or as a segment thereof. And this type of strategy can be related to a scaffold process, that is a scheme number 9 is shown over here. Look at this, the target molecule, and as already we know that target means what? Target molecule means what? The molecule whose synthesis being planned is known as a target molecule, that is a canisomycin. It is one of the target molecule is shown here, and here are the nitrogen atoms are present. How this nitrogen atom, look at, this is a segment or the carbohydrate type of the symmetry must be hidden over there, that is shown over here. And how we can introduce the nitrogen atom in that is imagine, and as we know that retrosynthesis, it is a imaginary but logical reverse chemical reaction which helps to reach the reactant starting from the target molecule is known as a retrosynthesis. So in that way, but that retrosynthesis we are using here is a Chiron approach or the Chiron perspective, so that this skeleton is shown over here, or in another way this structure and these three lines clearly indicate that they are the equivalent one, and that's why we are getting as this type of the aromatic compound. And now we can, here you remember that is aromatic moiety present over there, and we will see that one now. We can introduce, or you can imagine there at a 2 position there will be a aromatic compound over there, and by this furano, that is a tetrahydrofuranone type of the moiety over there, and this side there is a what we can call it as a pyridine type of the moiety also fused together, and there is a aromatic ring we can introduce there, and the zigzag line clearly indicate that bond we are that anomeric carbon atom, aromatic center, we do not know whether that OH is coming from above or below that, and at that moment that type of the zigzag line is drawn over there. And now look at here, and this can be obtained from this one. Look at here, 1,2 diol protection is carried out here, or that is shown over here. X is maybe as a one good leaving group, and this NH2 group is a reactive group. It can be attack on this with a stereochemical control, and we will get the pyrrolidine ring formation inversion. Inversion means what? There is a complete inversion means if you have a R configuration in a optically active substrate, when the product is formed, that should be the S configuration. So that type of the things are happening over here. Now look at this can be obtained from this just by introducing this NH2 group from here, and over maybe as a departure so that we can do this one. But this is one of the segment or the carbohydrate type of the symmetry is clearly apparent over here, appear over here, and this can be obtained from this. There is a invert of this hydroxy group over there. Look at 1,2 position, 1,2 position, that is a 1,2 diol is get protected, and protection group will be the acetone in presence of the acid. While studying as a protection and deprotection, we already seen that type of the structures over there, and this can be easily obtained from the D-glucose, and by D-glucose is a precursor or the chiral precursor used here for the synthesis of such type of the target molecule, and that is the explanation of scaffold process of this. This is a scheme number I think 9 is shown over here, scheme number 9, and how it is there. The synthesis of anisomycin, for example, is representative of this strategy, and in this case the critical pyrrolidine ring is formed by the intramolecular cyclization from a primary amine with the complete inversion of configuration at ring carbon atoms, and the original carbohydrate portion then becomes an appendage or an extension of the new heterocyclic ring. And note that in anisomycin the hydroxyl group corresponding to that at C5 in a D-glucopyranose structure, and the acetoxy group is derived from the ring oxygen, and the original stereochemistry at C5 must be inverted, but that at C4 is carried out over to this target, and the synthesis of crenanthamic acid can be thought to proceed by a scaffold process. So this is one of the thing we have seen over here. I think with this let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.